So today let's do the daily problems of the day. First of all, lead code daily problem is basically a simple question. Find if the path exists in a graph or not. So basically you have been given a graph, you have been given a source vertex and you have been given a destination vertex. You have to tell whether this path exists from the source to destination or not. So what would be the logic? The logic would be key to create first of all this graph, then start a DFS from your source point. Start a DFS from your source point, and uh, and make all the points visited that you can visit. And at last I will check, I have my visited vector over here in comma 0. At last I'll check return something like whether the destination is visited or not. Okay, destination gets visited or not. If destination gets visited before this, I'll call DFS from source vertex, and I'll check whether the destination is getting visited or not. If the destination gets visited, I'll say yeah, it's true. And if lazy, yeah, you just need to return whether destination is visited or not. So let's see the solution. Actually, it's pretty easy question. That's why it's rated easy also. Yeah, you can see I created the graph and visited a vector. Uh, you know, like outside all the functions, what I call it, global variables, so that I can use it in every function. I resized the graph and I created the graph how we create the graph g of one vertex dot push back another vertex, and then v dot resize visited to make it n size, and then I called on DFS of source, then I returned destination of visited, and that's about it. DFS was simple, just visiting every vector and going to every vertex. Sorry, visiting every vertex and going to every other vertex like adjacent vertex. Yeah, that's about it, and that was accepted. Pretty good efficiency. Let's go to the GFG problem of the day. This is basically you have been given a graph again. This is again a graph problem, and basically you need to tell that from one basically source, can you reach all the destination or not. If you can reach all the destination, you have to print the distance, maximum distance from a particular destination. So basically, you're fond of traveling, you have been given cities, you have been given weighted directed edges. This is a flight, basically flight taking off from here going to here, and the edge cost is basically distance, you can say, target node, and the distance that a kth city he wants to visit, one city of his choice, return the maximum money that he should require to visit any city. So basically, what is the maximum money that you will require to visit a particular city, that is equal to maximum money that you require to reach the farthest city. Because yeah, that's about it. So this is doesn't it look like Dijkstra that you have one starting vertex and then you have to see distance of every other vertex from this vertex? Yeah, that's about it. This is a Dijkstra algorithm, standard Dijkstra algorithm question. I created a graph and I pushed everything into my graph. Okay, I did first like this also, but this is not a undirected, this is a directed edge only. So just one thing like 0 dot push back 1, and distance I created initialized with 1e9, so that right, max infinity distance, and then priority queue, will be min priority queue to like how we do in Dijkstra, and then distance of k, the source vertex from it is 0, and I just push this and the normal basic Dijkstra algorithm while your q dot size, pushing out the first element, then checking all its adjacent neighbors, and then going to this and decreasing the distance of the neighbor based on the distance of the of this current element. And that's about it. And then at last you will return max element in all the distance vector, which means you will return the max element of all the distances between all the vertex. But one thing you have to see that, okay, over here the indexing starts from 1. That's why you have to take n plus 1, n plus 1. And then while seeing the distance, you should not consider 0. You should consider elements from the, vertex 1. And that's about it. And if this distance is equal to 1e9 means that's not possible to visit, then you will return minus 1. Whew. Let's try to submit this up. It should get submitted. Yeah, that's about it. Okay, guys, bye.